So we'll see the matrix. Yes. So this is something which is under system dot threading namespace again, right? Which is basically used for inter-process synchronization, which is like across asynchronous threads, right? If something is being called by multiple threads, right, then if you want to make it synchronous, right, then it is useful. Now let me take an use case here. So let's say you have a method, some method. I think we have already created that now. We have infinite method. Okay. We have created a separate class, right? Yeah. So here, what we thought of is, let's say I'm going to create a sum method, right? And we'll create few threads, right, which are going to call this method continuously. Let's say 4 different threads are being called, right? And all 4 methods are calling this sum method and doing some operation like passing on to values and getting some, passing on to values and getting some, and they are looping on, right? Then what happens is, if multiple threads are, repeating one single method, right? And let's say this method is going to take some time. Like let's say you have thread 1. Let's say you have some thread 2 defined, thread 3, thread 4 defined, right? Now let's say these 4 threads are going to call same method, right? These are intended to call the same method. Now this sum is going to accept 2 numbers, right? And it will sum up and it will return them. And it will return the result. So this is what is summary, which means now few things are, it will take some time for execution, let's say, right? Now it has to accept number, submit and return result, which means it is doing some task which is going to take some time, let's say, because we are going to create some wait over here, which means we are going to create a wait so that to actually keep some time in execution process of something. Now what happens is main intention. So whenever T1 is called, right? So let's say execution is going on. Immediately, whenever T2 request comes to sum and pass on 2 values, right? Then what happens is the immediate request will actually kill the previous request and it will start working on that, right? Now as execution goes on, right, with T3, let's say T2 got result, let's say, even before T3 got triggered to call the sum, let's say T2 completed, then now in T2 the result would have actually achieved successfully and it will go to T3. And let's say T3 is in progress of summing up, immediately T4 thread calls sum, then again it will be 3. Now this is how, one process, right, if other process comes up, right, now it doesn't have any automated queuing method, right? All the methods here are like, whenever you call, now if some other process is going on the same method, it will actually kill that, right? And it will start working on now. So here, in order to actually, get rid of that, what we are going to do is we have to sum up. Now, if you make this sum, right, as a asynchronous call, right, that is what is happening. Like where you may lose some data, or you may lose some transactions, right, or you may lose some important execution statements, right. Which means if we are actually making this to asynchronous call, there may be some problem, right? So that is the reason why we can't actually say that okay, multiple threads can't use this sum. No, only one thread should use this because there is a problem. No, that is not a solution, and it is not a good solution. Or you can't have a same method written 4 different times to actually make 4 different threads run, right? Which means if tomorrow, if anyone else have to create, if one more thread you created and in one more thread in some other method, if your sum method is being called, then again, which means you are actually writing it up again, which is not the solution, right? So here our mutex comes. Now, as you can see that our T1, T2, T3, whenever it gets triggered, right, they are asynchronous, which means sum being called by T1, immediately T2 called, which means it forces the sum to run asynchronously. But as it's a single entity, it may get affected due to multiple things. Now that's the reason why what we'll be doing is we'll be using a mutex class. Now this is something which will be used to queue up requests. So when you use mutex, right, let's say at the start of your sum method I used mute and then execution started, and after end of my all executions I unmuted it, right, which means when I start muting, right, which means until it is unmuted, no other process will disturb the current execution, right? Then what happens? It will complete all the executions and then it will unmute. What happens when it unmute? Then it is open to one more request. Then again unmute. Again open to one more request. Again execution completes again, which means our mute will make sure that one request will be processed at a time, which means all the requests whatever are coming up will be queued up, right? And one by one will be released. So that is something which will make your sum as inter-process synchronized. Why it is synchronized? Because when you execute, yes, it is synchronized because each and every statement will be executed till last. What is inter-process? It is asynchronous. Multiple threads are being called, right, to run this method. Now this is what we have in here to actually make our process, right, inter-process to be synchronized. Fine. So let's check real time how we can actually code that. So let me create, so in the program, let me move the static void so that I can play one more calling method here. Let's say I have static so from now on I will be using try catches for the main method or at least wherever they are needed, right? Sorry, was there any question? So let me create a new method by void sum, right? And what I'm going to do in here, so I'm going to take int I as I2, right? Or I'm going to do is I'll just use this I and int j, let's say. Right, these two are the numbers, and what I'm going to do here, I'm just going to print it. So I and j will be assigned in different threads over here, right? And we'll see how it works. So here, what I'm going to do here is I'll take one number while do that. Let's say these are some 20 administrative where I have some sleep for, okay. So I have to do all the trading to myself. So that I can actually say that sleep, let's say, second. Here what I'm going to do is I'm going to call some method with, let's say I, and let's say I, that's or let's say I do something, right? So I'm using the same I, right, to pass the values, right? So okay. Values rather as I in here. I'm going to take the direct values here. And what I'm going to do here is if any exception happens in here, I don't want to catch here, I want to throw it here, right? So we are going to see one more thing today, how thread gets killed in between if there is any exception. So here let's say I'm going to include some C as I plus J. So here, what I've done is I'm actually creating a locality. Now this is the one which will be called from methods. And what it is doing, it is continuously calling my sum for some iterations, right? Which means if I create multiple triggers for my locality threads, right? Which means multiple process, right? Or asynchronously my locality will be called where I'm actually looking on sum, which means multiple hits. If I create 4 threads, then you can see that some method will be called 80 times, right, asynchronously. So here let me create, and here let's say the sleep, whatever I'm actually doing here, let's say I'm going to do in the sum method, right, so that my 2 processes will hit. So if I'm up here, let me create, let's say 2 different threads. Let's create 3 different threads. So you can see here, I'll have to create an object for calci. So today we'll see a new way of creating object. You can create object even in this way. You just need calci here. Right, or cal. Now this is your object being created, and your method calls. You can also do this way. Right. Normally we create a separate object and provide, right? So how you do? You have your cal information is equal. Instead of data, and what I'm doing is I'm actually using this directly, right, which will give me some area. So what I'm going to do here, either you create this or create this. OBJ, which is an object, and provide this. Okay, so we will either you can create an object OBJ, or as I said, you can go ahead with the ID. So what it will do, it will actually create object for that moment, and until this thread is active, it will be using that. Even you can follow this, or you can follow the legacy one, which is OBJ. So same way, let me create one more thread, E2. Same, you can create any number of threads for your single method to make it as a right? You have even dot start. You have done dot start. I want to wait the result. So here you can see I've created multiple threads for do calci, right? So this will be called across. And in my do calci, what I'm doing here is I'm actually calling my sum method, which means triggers will be in multiple over here, right? So whenever we actually run this, it will start at a time where the do calci will be executed synchronously multiple times as this will be going on in. So in the, what we are doing is we are actually calling the sum method to do some operation where with some weight we are doing. So here we can do one thing now. So let's see more parameters of thread now using the same example. So as I said, in thread class, right, you can actually set some properties to thread. Like, let's say you have t1 dot. Let's say you have something called name property. Name is nothing but you can actually set the name of a thread. Like, let's say I'm going to take it as thread 1. So this is a name we are assigning to your current thread. Now, how does it work is, now let's say you're actually, are in some method and you want to get what exactly your thread name is, which is going on, right? Now you can call it anytime you want. Let's say I'm going to make it as console. Right. So I'll say threading. Current thread name. You see, you can actually get the current thread name. So your sum method will be called by multiple threads, right? So you can do as what exactly is my current thread. So this property will actually help you to actually get the thread name, right? Here you are actually getting what thread is running, right, and sum. And we are doing some way, which means current thread whenever it is running, some other will not be interrupted. We'll see, without mutex, we'll see how it is working and then we'll actually go ahead, right? Same way that we call thread 2 and thread 3 also 2 and 3. There we have here 2 and 3 threads. So this is one property. Same way we have something called t1 dot priority. Now priority is nothing but like on what basis you want to run this priority. Now you can see you have a thread priority. So you have all this. You have above normal, you have from 1 to 5, right? And normally, it will take as it will actually take input as an enum anyways, but internally it will be 1 to 5. By default, if you don't set any priority, it will be normal, right? There is a threads we have, you can see even the description here, threads have normal priority by default, right? And whenever you want to assign anything else, you can actually assign. But based on this, what happens is in your current task, right, your thread will be prioritized. Like to give an example, like in let's say in Word or in any editor, you are actually typing your to here. So let's say I'm actually typing something. Right? I just gave some value which is not correct and I moved on. Now you can see the background process actually ran and it is saying it does not contain this. What does it mean? It is giving me a high priority or the above normal priority or the highest priority to type my code first. Right? I'm typing my code and my editor is allowing me that on my as a highest priority. And then once my typing is done and when I actually move on to the next, right? Now when I click some save or something, then it is background is running anyways, right? Then you can see something else happening, right? So that is something how you set a priority. If you set it lowest, which means I say all objects, if you want whatever you have created, have to get clear like how the garbage collector works. So garbage collector works always in the lowest priority. Right? So that's the reason why we never, completely rely on guarded shutter. If your execution of your program is going beyond a memory where your processor may not allocate some memory for garbage collection process. Right? It can happen. It can happen real time. Right? So this is your priority as such. Where you can set. You can set for multiple threads. Right? Now you have something called ease background, ease alive or ease background. Now, ease background is nothing but it will actually run in a background with a priority set lowest among the existing threads. Right? So let's say there are threads running, right, which are running in let's say at least normal. Right, your background will actually go ahead with at least a below normal background. So that is something which is your ease background. You can actually set either a true or false for this. So these type of threads will be there. If you want to make sure your thread is alive, you have something called is alive. Now which will say whether your thread is going on, right? Whatever is going on is not killed. Right? Because it's intermittently, if your thread is obviously whatever thread object you are creating, right, we will be maintaining that, right? There will be some other thread or some other process where it will be checking whether your threads are running or not. Right? So there, ease alive will actually help you to make sure that thread is alive or not. Right? Those properties you can actually set to actually enhance the details and more processing. So here. So let's say we have actually used background 2 and highest. Let me just comment it out. Let's run all the threads in a normal priority and all the threads are active threads. Right? Now let's run this and see how it works. So here you can see here what happened. See first current thread, see everything figured on. So you can see thread 1, 2, 3, right? Parallel execution is happening, and you can see as different threads have different writing. You can see 1, 2, and 3, and in between you can see 1 and it skipped 3. Right? Which means parallelly they are actually hitting the sum. Right? So here, which means now you can see there are multiple ways which will do sum asynchronously. And we are not sure now which statement actually got it, right? Now here let's go ahead and use something called mute. Now your mute is, as I said, it's a class under your threading namespace that we use the name as obj mute. Let's say I'm going to create a mutex object here. Right? And how to mute and unmute is, let's say I want to use mute only here, or either you can use it here or during the execution process, let's say you want to use. Right? Either way you can use. Now let's say here, but there is, we'll actually see what effects we are going to get. Right? Obj, so we have removed so obj mute. I'm gonna take it as obj mute dot. Your obj mute dot wait one is nothing but your wait started and all the requests coming up will be queued up. And after this, let's say I'm gonna release it. Let's say, I'll just say as waiting for right, I'm going to increase the time now, which means multiple hits, but it's going to wait until I release the notice. Now I'm using it here, so let's run this program and see how it is. I can see here that I increase the time, but I can see that multiple threads are running. Right? But what happens is until the process is completed, right? No, it will not release it. So you can see multiple, requests are queued up. Whatever requests are queued up, it will complete that first. Until it completes, it will not remove. Now you can see from thread 3 there are multiple requests. Now you can see there are continuous requests from thread 3. Until it completed all the requests, it didn't actually went to the next one, right? Now you can see there are multiple requests at a time from thread 1, right? Now you can see that everything here, right, is being satisfied with whatever it was actually searching for. Right, so this is how it actually works out. You can see, right? So previously, if you have seen in our previous execution, right, it gave 1, 2, 3 and continuous, which means every request, your request 1 will be there, 2 will be there, 3 will be there, which means if there are multiple requests from 3, right, it doesn't matter, it will override them and your current request will be executed. But when you are using mutex, you can see until from one thread, let's say there are 2 different requests come up, right? If you complete that, and then it will move the request, right? So again, this is when you are using mute, which means you are actually stopping so many thread requests, right? And you can see there are around 80 requests which would have actually dumped into 80 now, 60. I mean, you are calling this for 3 different threads and you are calling each many times, which means 3 different execution processes will be running and your sum will be called around 60 times, 60 hits. But your mutex will be queued up and everything will be executed weekly. So that is how it is going. Now we have seen that how we have actually stopped the request and move it work in a single. So this is about mute. Now let's see what are the disadvantages if we have if you don't use mute in a right way. So what is happening here is, let's say whenever you mute, right, unless you unmute your mutex object, it always locks your sum, right? Once you start mute, it will lock your sum method to complete execution, and until you release mute, it will not release for some other request. Now what happens if there is any exception in between, right? So let's say I have int sum O is equal to 90 divided by sum x, and int x, I'm just doing some operation here, right? So for the first request, what I'm doing is I'm actually taking here, or not a first request, let's say I'm going to take some I minus some, let's say 10, right? Anytime whenever I comes, whenever the value of I comes to 10, right, it is going to hit the program, right? So at that time, what happens here? Let's take this out. Let me put it, now the first point here is whenever we get any exception, right? Now we have a thread which is running and we got exception in between, right? Here let me print the execution value. So I'm going to declare this I outside this, my value, so that we'll actually see what exactly is I feel what execution point it is. Fine. So let's run this program. Now it is coming to wait one because it has to come till 10. Let's step down the speed to 1 second so that it will actually go a bit slow. faster. Now you can see in thread 1, right, we completed 1, 2, 3, 4, 5 only, right? Somewhere it should actually get us 10, so that my x value, right, will become 0. So, and whenever we are dividing anything with 0, now you can see here we got an exception, right? And there is a value. Okay, it didn't print it because it is here, right? Now we got an exception. Now see, it's a factorial exception. We haven't printed the I value here, that's right. So here you can see whenever it completes execution, right, then it is printing. So let me print this in between. I would like to show you that. So before sum itself, let me print the I value. So I value 4, 5, 5 again, 6 again. You can see I value can be valid, right? 7, 7. There are 2 different requests again. 8, 8, 9. We got 10. You can see we got multiple 10s, but it is actually working here. Now you can see my value got 10 here, right? Then we got another. And you can see it actually intermittently skips this program to out. Right now this thread is killed. Almost this thread is not alive now. Now when I run this, I can see this is the second thread. Run this, third thread. Run this, and on. Which means all the 3 threads got killed. You can see that it is still at my thread 2 is still at 10, right? And you can see thread 2 is still at high. And my thread 1 is still at 10, right? Which means all the threads got killed intermittently. Now this is again something which is not good, right? Now which means now as my end method is not handling error, right, it will actually throw it to the mother call. But where am I handling the exception here? I'm actually handling it outside my loop. Now that's the reason why in your method, if you are trying to loop on the actual execution process, right, always use your exception handling here. It's very important. Now what happens here? Whenever there is an exception, right? Whenever there is an exception here, right, your exception will be caught here, but your execution process will continue. Right? Because we are actually using exception handling to actually hold or suppress the fatal error, right, or killing a any process. Now here, whenever any exception happens in sum, it will be caught, but your loop will continue, right? So here you can write continue. If you want to continue, you can write it over here. So that it will directly go here. Or you can actually, you don't have to, because if you don't write continue, it will come to the end again, it will go back and continue the process. That's how it works. But here, what is a guarantee is that your thread will not be killed until the complete process is done. So here, let me print this console dot right now. Let me print it as exception happen. Exception retrieved. Let me give some variable for that. Right, we got this. Now let me run this and see how it is going to work now. As you see, I value 1, 2, 2, right? Where multiple methods are calling the same. Multiple process are calling this. So I value between 4, 5 in some process. It is 6 now. 7. In some method called 8, 7, 9. Again it came to 10. So when it comes to 10, right? Previously what happened? Everything got stopped there. So this is in one thread we got exception, but it is moving on. Now you can see here, this is the exception what I am doing. The wait completed due to abandoned mutex. which means we got an exception in between. Now this is some other thread, attempted to divide by some other thread. Right? Now this is thread 1, let's say, thread 2 we already got, let's say we have to get in some more. Now you can see, we got exception at somewhere, let's say for thread 2, right? Thread 2 we got an error. Now you can see for the same thread 2 what happened? Whenever we try to call sum, right? It actually waited there, but it actually gave an error that your mute is still on. That's the reason why it is not allowing me. It's two different errors again. So first error what you are seeing, if any exception happens in sum, right? Now we should allow it to move on. Yeah, we are allowing it to move on. But what is happening here? Right? Whenever we are allowing it to move on, what's happening? It's not actually listening to our words, right? Which means it will come here and it will lock the sum, and in between the exception is happening, and we are not allowing it. Right? So here you have to actually write it smartly so that you can actually allow it to unmute. Now how to do that? Let's see the first one. So what I'm going to do here, I'm going to use my try finally. Now here I'll show you how it can actually use. Now here I know that I don't want to handle exception here. Right? So what I'm going to do, I'm going to use try and finally here. Now which means whatever happens I want to release a try finally, which means okay, an exception happened, that's fine, it will throw exception to calling method, but I have a finally which will unmute my execution. The first step. Now let's see how it works. So let me take something low speed here. Now here you can see 3, 4, 5, 1, I value 2, 3 are running. It came to 8, 9 we have 10 now. X, you can see, attempted to divide by 0. Right? Now you can see you never get that unmute, right? We got 3 different times attempted to divide by 0, right? Which is correct. Now you can see other sums we are getting, other sums here, right? Even after having attempted to divide by 0, we never got that your mute is on and it actually abandoned my wait to actually process. Now you can see there are sums even after we got an exception. We got exception whenever the value was 10. But when it moved on 13 we got some, 19 we got some, 14 we got some, 15 we got some, right? Now this is how what we did. We actually wrote our program smartly to actually handle exception, also to handle my mute and unmute. That's the best way to do this. Now here this is a situation where we are using try finally. Why? I don't want to handle my exception here. I want to handle my exception in mother method. Good for you, and go ahead. But at least what you have to do is you have to make sure few things, whatever should be done, even if you have exception or not, should be completed. So that's the reason why I'm actually tracking my exception and doing some final things, which actually makes my execution smooth. First way how you can do this. So other way how you can actually go ahead is, here you can actually use your mute, let's say, right? Normally it said, you can either use in sum or here both will be same. Let's say I'm going to use mute over here. Wait one. And any exception happens. No, I'm not going to do anything here, but I'm gonna make it. So you have your obj mute dot right. So I'm going to use it there. So let me just comment it out. Right. So I have a simple plain code where I'm not doing any mute or anything. Right? So I'm just using it for plain simple code where what I'm doing, I'm handling everything in my calling method itself. I'm taking care of. Right? Where I have my try, I'm handling exception, and also I'm releasing the main blocking resources. Let's run this. What happened? Okay. So you can see here, the thread is going on, and 7, 8, 9, 10, we got one attempt at 0. Now you can see one more attempt at 0, but the execution will not stop. At only that particular instance, whenever I value is 10, we got an exception, but yes, only that part got error, but we are successful in continuing for other iterations. Perfect. Okay. Now the execution is successful without any, fatal error. Right. So this is how, anything, whenever you are using wait or right, you're doing pausing, right, you have to do this. Right. Always try to use exception handling in between the main loop of your thread so that your thread is not killed. Right. On here you can see exception, some exception, you got some exception, and let's say you want to check whether your thread is alive or not, right? Let's see, and console dot write line, or let's say state. You can go ahead with thread dot current thread dot is alive, right? Is alive will give you whether your current thread is alive or not. Let me just run this program. You got it. Now you can see thread alive is true. Right? You can see there you will get one more error. You can see thread alive is true. Right? Which means if your loop execution gets killed abruptly, right, then you are going to get some issue like, okay, this is something which is not happening, right? But here, yes, you have a few things which can work right, and you have a smooth transition. And so this is about how we use exception handling and how we use mute to actually lock the things, right, and to check different other things in multi-threading. So this is something which we have in multi-threading, all the concepts we have. Now what are collections? Now this is again a very important service being provided by .NET. Now we normally call these as dynamic memory folders or dynamic storage, dynamic data storage classes which we can use. Now first let's understand why do we need this. So even before going to collections, let's understand what is the starting point to actually create collection items where we have some other already available resources, right? So if we come back to arrays, right? So we know that we used to use arrays in this way. Let's say if you want some arrays like int array. So go back to our same example which we actually took in our arrays class. Now if you have students in college, right? Let's say you have 10 students in college. What we used to do, we used to initialize array as 10. Okay. Now when you initialize array with 10, which means now this I will always can take only 10 values, right? Now here if you want to increase it, what you have to do, you have to increase your array size, right? Which means this is not dynamic, right? Which means your array here is not dynamic. It always depends on the size you give, and we can't actually dynamically increase your array size. It is not possible. So here, that's the first problem we have with arrays, that you can't actually increase it dynamically. The second thing is that you are actually restricting your type. If you create your int array, right, you can actually save or store data which is of type int. I can't save any string type into integer array, which is important because there is a type restriction which you have to, right? Obviously, if you want to go ahead with something dynamic, let's say you are actually getting some student's name, right, or student IDs. Let's say this is something which you are used to, save some data, right? Let's say we have a unknown database where your students are there, and you want to retrieve and save in some array. Now, how can we decide how many students are there? Obviously, we can't decide, right? It can be 100,000, right, 10,000. We never know. Now, which means I will not be able to use my integer arrays to store a dynamic things coming up, right? I can't declare a variable and then go and whenever I'm getting data dynamically, I can't store, because after some range, my arrays will actually be filled up and it will give you an overflow error or index out of range error. So that's the reason why I can't use arrays. So in order to make it both dynamic, right, and allow you to actually accept any object type, right, we have something called collections. Now collections are, again, you can say that this is a derived or the main pattern how it actually works is same as arrays. Like if you take arrays as one entity, then it will be a bigger entity than you have, where your working model will be the arrays. Fine. Now that's our main difference what we have. Now you can actually understand that when I'm relating collection with arrays, which means collections are somehow used to save data by creating a variable which can save multiple data in the same variable. That is something which is a straightforward understanding, right? Also, few more things is that collection item have got tendency to save any type, right? And also the working model of collections will be easy or much easier than your arrays, because in arrays you always have to go and work with indices. You have to make sure your index, whatever value you want, you have to remember the index. And one more issue which actually got solved in collections is, let's say if you define your int for int array with 100 size, right, then even if you initialize it or use it or don't use it, right, your array size is going to always be a 400 bytes, right, because each int is 4 bytes, and when you define your integer array of 100 size, it's always going to be 400 bytes, which means your I size is 400 bytes. It doesn't matter whether you are adding data or removing data or doing whatever. But it is not the case with collections. Whenever you use collection items, right? So initially your size of array size of collection item will, if you don't have any data, then there won't be any size except the object. And when you start adding values, right, with respect to the value you're adding, the size will increase with collections. And in between, if you remove something, right, that memory will be freed up from collections. Right? That's the reason why we normally got as a dynamic memory allocation. It is both ways, adding up, and even whenever you remove some data, right, it will be reverted back again. That is something which is a collections. Fine. So here we have some types of collections. Now on top, right, I'll give you a list of collections which you are going to see. You have array list. You have hash table, you have a stack, and you have a queue. And on top of your array list, we have something called list, which is again will be used for saving some data in some pattern. So all these are, you have when we have different collections and there are different usages what we have in here. So also we are going to see something called iDictionary. Very important, no? iDictionary, where you can actually save some key and value, but you can save multiple keys and multiple values with the unique nature of your key. Right? So these are different collection items we're going to see, and there are two main classifications which I'm going to see. One, we have non-generic collection items or collections, and we have your generic. Now, the main difference between non-generic and generic collection items are, in non-generic collection classes, right, you can have any object you can add to collection item, and you can actually work with any object as such. Here in my array int, right, I can actually provide only integer, right? Now here our non-generic collections will actually allow to add any object to it. Also, with this we also have a generic collection, which means you can add, if you want to go for specific collection. Let's say in this array list I want to say only or in this list you want to say only double data, then you can do that. How you can do it is possible with your generic way of using collection items. So we'll see both. First we'll see how the collections are working in different array lists, HTML stack and all. And then when it comes to generic collections, we'll see how to create a generic collection, right? What is the pattern to create a generic collection, and we'll see. And also, including this, we will also see how can we work with generics. Very important. So we'll see how internally our generic collections work. We'll also see how generic collections work and how can I create my own generic class to actually work. Right? We'll see both the patterns how it's going to work. Right? So this is about things what we're going to see in collections.